Hi, everyone. Before we get started today, I just wanted to draw your attention to a study that's going on right now. This is a study that's actually being conducted by one of my graduate students. I've got it up on the screen so you can read a little bit about it, but he's looking for participants in the study. Of course, the extra credit that you can get by participating in this study, you can use towards this class or any other class if you want. It's a two-part study, and you can get up to 3 SONA credits. And remember, I double everything SONA gives you. So if you can get 3 credits from the study, I double that to 6. So if you are interested in participating in this study, he's looking for people. He will be looking for people probably through most of the semester. But the sooner you can sign up, the better. It's called Virtual Problem Solving. You should be able to find that in SONA. Okay. With that being said, I had asked you to get a Top Hat account. We're not going to have a Top Hat quiz today. So we are going to do our first Top Hat quiz probably almost certainly next class on Tuesday. So if you haven't got the Top Hat account, you have a bit of a reprieve. Just make sure you get that account set up for Tuesday's class, and then we'll start using Top Hat then. Okay, so let's continue where we left off. And I just started talking about how we conduct research in social psychology. Remember, the theme for today, which is based on what we did last class. Remember last class, I had a little magic trick, and there's a theme, a lesson to be taken from that trick, which was that the amount of control that a researcher has over a study is proportional to the strength of the conclusions they can draw from that study. And so in today's class, we're going to look at 3 types of research that vary in terms of how much control the researcher has over that study. And consequently, the strength of the conclusions that they can draw on the basis of that study gets stronger as the amount of control increases. So we're going to see how that works. But before we get there, I was briefly talking about how we go about choosing a sample of participants to be in our study. And I just introduced this idea last class. I want to continue where we left off. Okay, so if you recall, the first thing to do when deciding who to pick to be in your study is to figure out who your population is. And the population, just to refresh your memory, is the group of people that we want to generalize our findings to. And so again, if we think we have a theory of human behavior that applies to everybody on the planet, then technically the population is everybody on the planet. If we think it only applies to, let's say, Americans, our population is Americans, etc. Once we have identified our population, then there's only one procedure that ensures that we can generalize our findings from our study to the population at large. And that's through a process known as random sampling. So let me describe to you what that is and why that matters. Random sampling means that everybody within your population has an equal chance of being in your sample. Okay, so for instance, if I was conducting a study, let's say that we were in person, and let's say there was a class of 100 people that I was teaching, and I wanted to test a theory that I believed applied to everybody in that class. So the 100 students in the class were my population. If I want to pick a sample of 10 people to do my study on, then the way that I pick that sample is to randomly pick out of those 100 people in my class. So everybody in the class has the same chance of being in my study. What I wouldn't do is something like just pick people who are sitting in the first 2 rows to be in my study. That's not random, right? That means that the people in the front row are going to be in my study. People in the back row are not going to be in my study, so people don't have an equal chance of being in the study. That's a non-random sample. And the reason that's a problem is because a non-random sample, such as people who only sit in the first 2 rows, those people might differ from the other people who don't sit in the first 2 rows. So for instance, maybe people who sit in the first 2 rows have worse eyesight, and that's why they're sitting there. Or maybe they are sitting there because they want to make sure they're paying attention. So maybe they're going to try harder. Maybe they're going to be better students on average than people who sit back in the classroom. The point is that if I don't pick randomly, that sample of people that I get is not really representative of the group at large. And if they're not representative of the population, that means we can't generalize our findings from that sample to the population. Okay, so that's the main purpose, or that's really the purpose of random sampling, is to ensure that our sample that we get for our study is representative of the population at large. And that's the only technique that we can use that ensures that our sample is representative of the population. This is effectively the reason why when someone is on trial for a crime and they're tried by a jury of their peers, the jury is assembled through a quasi-random sampling process. It's not purely random sampling, but basically, if you ever get a letter in the mail saying you've been selected to sit on jury duty, that means you were selected randomly, because the idea is that we want a jury to be representative of the population at large. And the only way to ensure the jury is representative of the population is to basically pick them randomly. So that's effectively why jury selection is a quasi-random process, to ensure the jury is representative of the population. Okay? So the point of random sampling, therefore, is in order to generalize our results from our sample to other people who didn't participate in our study. We can only do that if it's representative. But that being said, almost no study in psychology actually randomly samples. And the reason is because it is virtually logistically impossible. Because if we have a theory about human behavior that we think applies to all humans, in order to randomly sample, we'd have to randomly pick from people around the world, right? And that's just impossible to do. We can't do it. So what we have to settle for in psychology is what's called a convenience sample. And that basically means you guys. College students are really convenient to researchers because we teach you guys. You're available to do extra credit for us, right? So as a consequence, the majority of the studies that we conduct tend to be composed of college students. And that could be a bit of a problem because you guys are a little bit different, in some cases a lot different, from non-college students. You're going to tend to be somewhat younger than the average person. You're going to tend to be more intelligent than the average person, et cetera, et cetera. Now, we know that because you're not a representative sample, we can't always generalize the findings with you guys to the population at large. So in reality, the way this works is that although random sampling is ideal in many situations, and although it is really important in certain fields, like for instance, if you want to survey people about political data, if you're trying to predict elections or things, then random sampling is really important. But in our studies, we can't really accomplish that. So we have to be aware of the limits of our ability to generalize our findings from our sample of college students to other people at large. Well, let's talk about the importance of random sampling as it pertains to collecting, let's say, survey data, polling data. Okay. So I'll tell you a little story. This is a story where there were a couple of different groups that were trying to predict the outcome of the 1936 presidential election. Okay. So this is a US election, so the population has to do with US adults who are going to vote in that upcoming election. And one organization, Literary Digest, they were trying to predict the outcome of this election. And they conducted a massive survey. And on the basis of the results of their survey, where they asked people who they were going to vote for, they predicted that Alf Landon, the Republican, would win the election with 57% of the vote. As I said, this was an absolutely massive survey based on a sample of over 2 million people. That is a humongous, humongous survey. We conduct surveys now with nowhere near that many people in them. Our surveys now are like 1,000 people or so. So this is way, way, way larger than surveys we have today. On the other hand, at the same time, a guy by the name of George Gallup, who would later be responsible for Gallup polling, which you might have heard of, he went out and he collected data from a bunch of people, and he came to basically the exact opposite conclusion than Literary Digest did. He concluded that Roosevelt, the Democrat, would win with 56% of the vote. Now, his sample was based on only 50,000 people. Okay, it was, 1/40th the size of Literary Digest, right? So a much, much, much smaller sample. So he had the exact opposite prediction than Literary Digest. Well, if you know anything about American presidents, you know that Roosevelt actually won the vote with about 61% of the vote. Okay, so Gallup turned out to be pretty accurate. Literary Digest, though, on the other hand, was way off in their prediction, right? So what happened in this election? Well, when you look at their strategy they used for how to sample people, what you found was that what Literary Digest did is they went through phone books and they randomly picked people from phone books. They had lists of people who had subscribed to magazines. They randomly picked people off those lists. It seems like a pretty random process. Turns out that was not random at all. Because in 1936, we're only a few years after the Great Depression, and a lot of people didn't have a whole lot of expendable income. And at the time, owning a phone was something you could only do if you had a lot of money. Having a magazine subscription was something you could only afford to do if you had a lot of money. So Literary Digest, what they had done by picking names out of phone books and magazine subscription lists is they had accidentally sampled people who had a lot of money. And people who have a lot of money tend to be more likely to vote Republican. So what that means is they accidentally oversampled Republicans, and hence their prediction that the Republican would win the election. On the other hand, George Gallup used a much better process for randomly picking people. And as a consequence, his prediction was much more in line with what actually happened. Okay, and so this demonstrates the importance of random sampling. In fact, and there's a big lesson here, right? Because if you look at the sample size, we're looking at a sample of over 2 million people, which led to the wrong prediction, a sample size of only 50,000 people, which led to the right prediction. So what's the lesson here? Well, it's a lesson you might have heard in other contexts. Size doesn't matter. Okay? It's the technique that you use that matters. Okay? It doesn't much matter how big your sample is. If you get to about 1,000 people, as I said, that's roughly the size of what people use nowadays for polling. And we can get really accurate polls with only about 1,000 people, as long as they're done correctly, as long as we can randomly sample as much as possible. It's the technique you use, the random sampling, that matters much more than the size of your sample. Here's another example. This is a famous picture. This is Harry Truman holding up a newspaper, the Chicago Daily Tribune, with the headline, "Dewey defeats Truman in an election." And why is Truman smiling so much, you might ask? Well, it's because the Chicago Daily Tribune miscalled it. They accidentally printed this saying Dewey defeats Truman based on some polling that was not based on random sampling. As a consequence, they mispredicted the election, and that led to this famous picture. But Truman actually won that election. Okay, so I mentioned that I was going to talk about 3 types of research. So what I'm going to do, I'm going to start by talking about the type of research, which is observational research, in which the researcher has the least amount of control. And as a consequence, they can make only the weakest conclusions on the basis of this research. So as the name implies, observational research involves research in which people observe other people behaving and measure their behavior. And there's a number of contexts in which you can do that. So you've got a situation in this picture where you've got someone behind glass watching, I don't know what she's watching, but maybe she's watching how children interact with their parents or something along those lines, right? You can imagine some type of research where maybe people are interested in, let's say, bullying on the playground among elementary school kids. And so maybe what they can do is they set up video cameras and they record what happens on the playground during recesses, and they can code and they can measure and see how much bullying is going on the playground, something along those lines. Or maybe you go to a mall, maybe you're interested in knowing something like who initiates physical contact more when you have a conversation between a man and a woman. Do men physically initiate contact? Do they touch women first more than women touch men first? And so you might go to a mall, sit on a bench, and simply record these behaviors as they occur. But it was only last class that I had said that if we're going to do stuff scientifically, if we're going to collect data scientifically, we can't simply observe people, right? Because our own biases creep in and influence the way that we interpret that behavior, right? So how can you conduct observational research if that's the case? Well, it's for this reason that observational research, if you do it properly, there's a number of different methodological strategies you have to engage in to minimize the likelihood that our own biases and expectations and values can influence the way that we interpret behavior. I'm going to give you an example of that in a second. For now, just know that the main purpose of observational research is to describe social behavior. Okay? So as we're going to see with other types of research that explain behavior, we can't do that with observational research. We're not going to be able to explain behavior, and you'll see why later on. We can only describe behavior. We can say that this type of behavior occurs. So we can say that, for instance, let's say that our data show that men touch women more than women touch men. So we can say that that occurs when we describe it. Or we can describe how often acts of aggression or bullying happen on the playground through observational research. But we're limited to only being able to describe that behavior. Okay, so As I mentioned a second ago, there's a number of methodological strategies we have to use when engaged in observational research to minimize the likelihood that our interpretations or observations are biased by our expectations. And one of those choices, or one of those methodological strategies we have to use, is to use what's called an operational definition. Because there are many behaviors we might be interested in, such as, let's say, aggression on the playground, that the definition of aggression is a little bit fuzzy. And my definition is going to be different from your definition. And so what that means is that if we're dealing with two different definitions of aggression, and I observe behavior and you observe behavior, we're going to come to different conclusions. For instance, on the playground, you might have two people who are kind of roughhousing together, and it's kind of ambiguous as to whether that counts as aggressive behavior or whether it's just sort of rough playing with each other. And maybe you think it's aggression and I don't think it's aggression. And so as a consequence, we're going to have different interpretations of the same behavior. And that's going to be a real problem. We need to be on the same page, right? So what an operational definition does is it takes some ambiguous behavior, some fuzzy behavior like aggression, and it defines it in terms of observable, concrete, measurable qualities. When we look at aggression towards the end of the semester, we're going to see what the operational definition is that social psychologists often use to measure aggression. So we're going to come back to that later on. But these sorts of fuzzy ideas or fuzzy concepts pop up all the time in psychology. So I just mentioned this example here. How would you define aggression? Well, you might define it differently than me, but in order for this to be scientific, we have to have a common basis, common understanding, a common definition that we're using. But there's many other areas in which there's ambiguous behavior as well. Take something like alcohol intoxication, right? What qualifies as intoxicated to you might be different than what qualifies as intoxicated to me. So we need to define it somehow. Now, we often do this legalistically. So for instance, if you are going to be pulled over because you're drinking and driving, the standard that's often used in a lot of states, most states, is if you have a blood alcohol content of 0.08 or above, then we're going to call that intoxicated. But that's an operational definition. That's defining a fuzzy concept like intoxication in terms of a very concrete behavior, a very concrete outcome, which is your blood alcohol content. But you're not limited to only using blood alcohol content. You could define it in other ways as well. You could say something like if your reaction time, your physical reaction time slows to only 90% of what it normally is, then we could call that intoxicated. Or we could define it by saying if you slur 5% of your words or more, then we're going to call that intoxicated. The point is that there's any number of definitions that we can come up with to define some concepts. We're not trying to find the right definition. There is no right definition. What we're trying to do is just have a concept that we define it so that when I write up a paper, I can define exactly what I meant by aggression or intoxication or whatever, so that every other researcher knows exactly what I mean when I say I looked at aggression or I measured alcohol intoxication. That's the main point, making sure we're all on the same page. Or take a concept like loneliness. So some social psychologists study loneliness. How do you define loneliness? I mean, we might think that we might define it in terms of the number of friends that someone has, but that's not really right because some people are happy with 2 friends. Some people feel lonely with 10 friends. So this is sometimes defined as when the number of friends that you want is greater than the number of friends that you have. We're going to call that loneliness. But note that we're not defining loneliness in terms of the subjective feeling that people have, because we can't really measure that. But we can measure the number of friends that people claim to have and the number of friends they want, right? So we can define it in terms of observable behaviors. Or kind of the $64,000 question is, how do you define intelligence? And this is a question that has plagued psychologists for hundreds of years, right? We still don't have an answer to this of how to measure intelligence. We have things like IQ tests, which measures a very specific type of intelligence, but it probably doesn't encompass everything we mean by intelligence. So we can use people's IQ scores as our operational definition of intelligence, as long as, again, we tell people that's what we mean, okay, when we say the word intelligence. But of course, again, there's many, many other ways you can define intelligence as well. One big advantage of using observational research is that we can study various psychological phenomena in naturalistic and real-world settings. So in the examples I gave you, we talked about looking at aggressive behavior on the playground. So you're seeing that behavior as it actually occurs. You're not bringing people into an artificial lab scenario, right? You're seeing it as it actually occurs in the real world. Or if we go to a mall and look to see who initiates physical contact more, men or women, we're going into the real world and studying this real behavior as it actually occurs. And that's the main advantage of using observational research. We're not creating these artificial scenarios. The disadvantage to observational research, and there's a couple. The first is that certain behaviors are just difficult to observe, right? There's certain behaviors we can't engage in observational research with. So for instance, there's certain behaviors where there's legal issues involved. So there are people who study, for instance, how juries reach decisions, how they come to verdicts, right? But legally speaking, we cannot get into a jury room to see how actual juries deliberate. Legally, it's just not allowed. No one's allowed in that jury room. So we can't use observational research with juries for legal reasons. Or take something like sexual behavior. Some psychologists study sex, right? And various issues surrounding that. That's also very difficult to do observationally, right? You can't go peering in people's windows, obviously, for obvious reasons. That being said, you might have heard of Masters and Johnson. They are two sex researchers, and they would bring volunteers into the lab and watch them have sex in front of them. So they actually did conduct observational research that way. Now, there's certain questions about that because the people who might volunteer to be observed while having sex with their partner probably aren't representative of the population at large, right? So we don't have random sampling, obviously. So although, and I think I've heard it said something like, they mentioned in the course of their career, they've witnessed like 10,000 orgasms or something as part of their research, like watching people in the lab, something like that. The point is, except in those extreme circumstances, it's kind of difficult to observe certain behaviors. But maybe most relevant to what we're talking about right now is that the main disadvantage of observational research is that the experimenter has very little control. The experimenter is not controlling the situation. They're not setting up the environment. They're going into the real world, right? So they have like no control over anything. And because they have no control, remember the theme for today's class is that when you don't have any control, you can't come to really strong conclusions. And so that's why observational research can only describe behavior. We can use it to say, here's what actually happens, but we can't say why it happens. If we see, for instance, that men touch women more than women touch men, we can say that it happens, but we can't say why it happens because we need to have much more control over the situation in order to make those causal conclusions, as we're going to see. Okay? So a lack of control in observational research means we're limited to only being able to describe behavior. A second type of research we might be interested in conducting is what's called correlational research. In correlational research, you measure two variables and you determine the extent to which those variables are related or associated with one another. So for instance, maybe I'm interested in looking at the relationship between high school students' popularity and their self-esteem. Is there a relationship between those two variables? Are students who are really popular, do they have higher self-esteem than students who are not popular? Okay, now what I'm looking at then is the association between popularity and self-esteem. Okay. Now, in theory, these studies can be easy to conduct. I can go into a high school classroom. For every student in the classroom, I have some measure of their self-esteem. I have to operationally define self-esteem, but I can do that with certain scales. I can measure how popular they are using various techniques. And then once I have those data, once I have some measure of self-esteem and popularity, I can use statistics to correlate those things. Now, the value of a correlation, so it's a numeric value. And that numeric value represents the degree of association between two variables. Now, a correlation is defined in terms of what's called a correlation coefficient, which is a lowercase r. Now, that number, that correlation can vary, can be any value between -1 and +1. And the number of that correlation gives you two pieces of information that are important. The first piece of information is whether it's positive or negative. Now, I'll make this, or I'll explain this a little more in the next few slides. But a negative number means there's a negative correlation, which means as you increase one variable, you decrease the other variable. A positive number means there's a positive correlation such that as you increase one variable, you increase the other variable. That's going to become much more apparent on the next couple slides, though. The other piece of information contained in a correlation coefficient is the magnitude of that number. And so the closer that number is to either -1 or +1, the stronger the relationship is. As that number gets closer to 0, there's a weaker and weaker relationship until you get a score of 0, in which case that means there's no relationship at all. So let me explain this a little bit more in the next couple slides, which will show this graphically. Now, the point is, and I'll show you this on the graphs as well, is that we can use correlational research to predict social behavior. And I'll explain what that means in a second. Okay, so let's say we're measuring two variables here. Okay, let's say we're looking at the relationship between the number of hours someone spends watching television and how aggressive they are. We want to see if there's a relationship between those two things. So let's say that I go out and I get my sample, say my sample is 40 people or so. And for each of those 40 people, I have some measure of how many hours they spend watching television and how aggressive they are. And I can plot those 40 people on this graph. So each one of these black dots represents one person. So this person here watches very little TV, which is why they're on the left side of the screen. And they're not aggressive at all. That's why they're on the lower end of the screen, right? This person watches a lot of TV and they tend to behave really aggressively. So let's say my 30 or 40 people are right here. Now, what I can do is using various statistical techniques that you don't have to worry about, I can put a best fitting line through these dots, right? So I can represent all these people with one line. Okay, now you see the fact that the line is sloping up and to the right. That means that the correlation is positive. That means that on average, people who watch more television are also more aggressive. As you increase one variable, you're increasing the other variable. Okay, that's always going to be a line sloping up and to the right. Now, the other thing you might notice is how tightly clustered these dots are to this line. So if all of these black dots formed a line themselves, they all fell right on this line, that's a perfect correlation of positive 1.0. To the extent that those dots spread out like a cloud around the line, the correlation gets lower and lower. So this might be a correlation of, I don't know, 0.7 or something along those lines. Okay, now I mentioned a second ago that we can use correlational research to predict behavior. And here's how you would do that. Let's say that we collected data on 40 people and this is our best fitting line. Okay, so this describes the relationship. And let's say we come across a new person and we don't have any data on this person, except we know how many hours they spend watching TV. And we want to use that to predict how aggressive they're going to be. Let's say they watch 2 hours per day. And let's say that's right around here on the x-axis, okay? If I want to predict how aggressive they are, I find how many hours they spend watching TV. Let's go to. I go up to the best fitting line right here. And as soon as I hit that line, I go over to the y-axis. And that is my best prediction for how aggressive that person is. Now, if this correlation had a value of 1.0, that means that it would predict things perfectly. So if I knew how many hours someone spent watching TV, I would know perfectly how aggressive they were. That never really happens in psychology. You never have perfect correlations. So I'm able to predict with some confidence that they're somewhere around that aggressive. I'm going to be wrong sometimes, but I'm mostly going to be, it's going to be in the ballpark usually, right? So to the extent that the stronger the correlation is, so the closer the number is to 1 or -1, the stronger my ability to predict one variable on the basis of the other. And I can do the opposite as well. If all I knew about someone was how aggressive they were, I can use that to predict how many hours they spend watching TV. So if I come across someone who's really aggressive, so they're up here on the y-axis, I can just draw a line, a horizontal line until I hit the best fitting line, and then I go immediately down, and that's my best estimate of how many hours of TV that they watch. Okay, so this is an example of a positive correlation between two variables. Here's an example of a negative correlation. Let's say that I'm interested instead on the relationship between how many hours someone spends watching television and how many hours they spend studying. And so I take a sample of 30 or 40 people. For each person, I measure how many hours they spend watching TV, how many hours they spend studying, and I graph those people in a plot here. And again, if I put a best fitting line through these dots, it would be sloping down and to the right, okay? And that's the hallmark of a negative correlation. It slopes down and to the right. Now, again, and just to answer someone in the chat, so what does it mean by perfect negative correlation? Well, perfect negative correlation would be if every single dot fell exactly on this line, right? To the extent that those dots are spread out like a cloud, the number is getting closer to 0. So again, we've got a correlation probably about negative 0.7, something like that here. And again, if all of you know is this correlation, we can use this to predict how many hours someone spends studying based on how many hours they spend watching TV. If someone spends only an hour watching TV, let's say they're somewhere around here, I go up to the best fitting line, go over to the y-axis. That's my best guess for how many hours they spend studying. Okay, so if we talk about positive correlations and negative correlations, we have one last thing to talk about, which is when there's no correlation between two variables. So I'm interested in how many, the relationship between how many hours someone spends watching TV and how tall they are. And you can use your common sense to figure out that there's probably no relationship, right? How tall you are has nothing to do with how many hours of TV you watch. So if I were to take 40 people in my sample and graph them, it'd just be dots everywhere, right? And if I tried to put a best fitting line in these dots, it would be flat. A flat line means there's no correlation between two variables. And when there's no correlation, it means you can't predict one from the other, which makes sense, right? Because if all you knew about someone was how many hours do they spend watching TV, we can't use that to predict how tall they're going to be. It doesn't matter if they spend like half an hour or if they spend 5 hours. It doesn't matter. It gives you the same prediction because it's totally irrelevant to how tall someone is. Okay, there is one major limitation of correlational research, and you might have heard something like this in other classes, or if you haven't, you likely will in the future, the phrase that correlation does not equal causation. This is extraordinarily important because a lot of people mistakenly believe that if you see that two variables are correlated, that you can form some sort of conclusion about which variable causes which other variable. It's a common mistake that people make constantly. I'm going to give you a bunch of examples in a second. The point I want to make, though, is that just because two variables are correlated with one another does not mean that you can that tells you which variable causes which other variable. And I'll give you the reason for why this is the case. First off, there's a direction of causality problem. So let's say that we're interested in two variables, variable x and variable y. Oops. And let's say that we know that they're correlated. There's a positive correlation between x and y. Okay? Well, why would that correlation arise? Why would those variables be related? Well, one possibility is that variable x, whatever that is, causes variable y. And if x causes y, of course they're going to be related. And I'll make this more concrete in a second. But it could also be the case that x doesn't cause y at all. It could be the case that variable y causes variable x. That would also produce a correlation between x and y. And so the fact that you have a correlation doesn't tell you whether it's because x causes y or y causes x. So for instance, let's say that we're interested in looking at the relationship between how much violent TV someone watches and how aggressive they are. And let's say we find a positive relationship such that in our sample, people who watch more violent TV tend to be more aggressive. Why is that the case? Well, maybe it's the case because watching violent TV makes people aggressive, in which case that would explain the correlation. So variable x is causing variable y. Watching TV is causing aggressiveness. But we don't know that for sure because it could be the case that people who are naturally aggressive just tend to gravitate towards violent TV, and that's why they watch more violent TV. So it could be the case that violent TV doesn't cause aggression at all. It could be that people who are aggressive already tend to like to watch violent TV. Just knowing the correlation doesn't tell you which of those two explanations is correct. And so it's a mistake to assume that one of those is automatically correct just because you have a correlation between the two of them. Okay, that's one reason why you cannot infer causation from correlation. But there's a second reason as well, something called the third variable problem. Because it is possible for two variables to be correlated with one another, even though neither of them causes the other one. And that's going to happen when you have a third variable. So let's go back to the same example we were using. Let's say again that we've collected data and we have shown that people who watch more violent TV tend to be more aggressive. It could be the case that violent TV causes aggressiveness. It could be the case that people who are aggressive watch violent TV. But let's say that neither of those are true. It's still possible to observe a correlation between these two variables because of third variables. So for instance, let's say that in our sample of, let's say we did a sample using 100 kids. And in that sample of 100 kids, 50 of them came from families where their parents paid a lot of attention to them, and 50 of them came from families where their parents did not pay much attention to them. Well, what happens is that if you come from a family where your parents don't really pay attention to you, so for instance, they're not monitoring what TV you're watching, well, coming from a family with neglectful parents might tend to result in kids that watch a lot of violent TV because their parents aren't monitoring their TV habits. Also, these same kids who come from families of neglectful parents, well, they also might tend to be more aggressive because their parents aren't punishing them whenever they're aggressive. So the 50 kids who come from families with neglectful parents are going to tend to watch a lot of violent TV, and they're going to tend to be aggressive. Not because violent TV or aggressiveness cause each other, but because they both come from the same third variable. And so what that means, and by the way, I should say that there are, in theory, an infinite number of these potential third variables that can exist, right? I picked one, neglectful parents, but there could be tons of other potential third variables that can explain relationships between two other variables. So what this means is that whenever you see a correlation between two variables, there are always, at least in theory, three possible explanations for why that correlation exists. It could be the case that variable X, so the amount of violent TV someone watches in this case, leads to variable Y. It causes variable Y. It can cause aggressive behavior. It could be the case that variable Y, aggressive behavior, causes variable X, so it leads people to watch violent TV. Or it could be the case that there's some sort of third variable, such as neglectful parents, that causes both X and Y, even though X and Y have no relationship to each other directly. Okay? So it's for this reason that there are always three possible explanations for a correlation. It's for this reason that we can never infer causation strictly from a correlation. But there are many situations in which it's extremely tempting to do so. And we can very easily fall into this accidentally by accidentally assuming causation from a correlation. And I want to give you some examples of this. Here's an example. Well, first off, before I do that, hopefully this example will make things clear if you weren't clear with the third variable issue. This is a true real world correlation. So what this correlation is between cities. It looks at cities and it looks at how much ice cream they sell within that city and the crime rate of that city. And what they show is a positive correlation, meaning cities that sell more ice cream have more crime than cities that sell less ice cream. That's a real correlation that exists. So given what we know about the reasons for correlations, let's look at some possible explanations for why that might be the case. Okay, so our variables X and Y are going to be the amount of ice cream sold and the crime rate for that city. So the first possibility is that variable X causes variable Y. So in that case, that would mean something like maybe there's some chemical in the ice cream that when people eat it, it leads them to go into murderous frenzies and commit all sorts of crimes, right? If that were the case, obviously it's not the case. If that were the case, that would mean that ice cream is leading to increases in crime rate. It's causing the increase in crime rate, okay? That's theoretically possible, but it's not actually what's happening, right? No one really believes that's actually happening, so that's not really gonna work as an explanation. Let's look at the second explanation. Maybe it's that variable Y causes variable X. So in this case, that means that the crime rate would cause increases in the amount of ice cream sold. So for instance, maybe criminals in particular just love to have a cone after they've robbed a house, right? And so they go out and they immediately buy ice cream. And if that were the case, then of course we're gonna see that cities that have higher crime rates and more criminals, they're gonna sell more ice cream to the criminals, right? And although that's theoretically possible, that's not really what's going on here, right? What's really happening, what's really explaining this correlation is a third variable. Does anyone know what this third variable is, by the way? Feel free to write it in chat if you think you know what this third variable is. That's causing both the amount of ice cream sold and the crime rate. Karen, you got it right away. That's exactly right. So temperature is the main third variable. Cities that are hotter sell more ice cream for obvious reasons, right? We sell more ice cream in Miami than I assume they do in Juneau, Alaska. Furthermore, for reasons that we're going to see later on in the semester when we look at aggression, we're going to see that temperature leads to increases in aggression and crime. As a consequence, cities that are hotter, like Miami, sell more ice cream and have higher crime rates than cities that are cooler, such as, let's say, Juneau, Alaska. And as a consequence, you get this association, this correlation between the amount of ice cream sold and the crime rate. Okay, now this is an example where it's really obvious that X does not lead to Y and Y does not lead to X, right? It's really obvious there's no direct relationship between ice cream sold and crime rate. But there are many, many situations where it's not nearly as obvious. And as a consequence, it's really, really tempting to assume there's a specific causal effect when we read about a correlation. I'm going to give you some examples. These are all examples that I came across in either online or in some news media source, where the person writing the article mistakenly assumed that there's a specific causal direction on the basis of correlational data. So for instance, this was based on a study that showed that people who smoke marijuana were more likely to have psychiatric disorders than people who did not smoke marijuana. And the person who came across this study, which was correlational in nature, mistakenly concluded that smoking marijuana causes psychiatric disorders. Okay, now again, we can't infer causation from correlation. They assumed that what this study demonstrated is that smoking marijuana caused people to develop these mental disorders. But there are other explanations as well. That's an X cause Y explanation, right? Well, there's a Y causes X explanation. Maybe it's the case that people who already have psychiatric disorders tend to be more likely to smoke marijuana because that provides them some relief for their symptoms. Right? And so we can see that both of those explanations are possible. And so we don't know which one is accurate just by knowing the correlation. And of course, there could always be third variables here as well. This was another article that came out that said that kids who sleep with the lights on are more likely to develop myopia meaning like short-sightedness, than kids who sleep with the lights off. And on the basis of that correlational research, the person, the news reporter, whatever, mistakenly said sleeping with the lights on causes myopia. But there's another explanation here. What's likely going on is a third variable explanation. Let me explain it to you. So myopia tends to be genetic, so that if a kid has myopia, that means they probably inherited it from one of their parents. So what that means is that kids with myopia tend to have parents with myopia. And parents with myopia tend to like to leave the lights on when their kids are sleeping, so that if the kid wakes up in the middle of the night, they can easily see when they go into the room to try to comfort the child. Right? So what that means is that parents who have myopia is our third variable. Parents who have myopia, that leads to kids who have myopia, and it also leads to them leaving the lights on in their kids' room. As a consequence, you get this correlation between children with myopia and having the lights left on, even though there's no actual direct causal link between those two things. A correlation still arises because of this third variable. So that's a mistaken conclusion. This is a study that showed that people who go to church tend to have fewer illnesses than people who don't go to church. And so they mistakenly concluded that going to church boosts your immune system. That's a cause. Boost is just another sort of causal claim, right? Going to church causes you to develop a better immune system. There's a much simpler explanation as to what's going on here, though, which is that if you're sick, you can't get out of the house to do anything. You can't go to church, but you also can't go to school or the movies or dinner or the mall or whatever, right? So what's probably going on here to explain this correlation, it's not that going to church causes you to become healthier, it's that only healthy people are able to leave the house to go to church or wherever else. So instead of X causing Y, it's more like Y causes X. Eating candy will help you live longer. Okay, I will show you the article where I got that from. Where's that? That's here. Okay, eat sweets, live longer, right? They're implying a specific causal relationship. However, this was based on correlational studies. What they did is they looked at whether people ate candy or not, and then looked to see how likely they were to die in the next like 30 years or something along those lines, right? And they showed that people who ate candy were less likely to die than people who didn't eat candy. And on the basis of that correlation, they mistakenly concluded that if you eat candy, you'll live longer. Okay. Now that's problematic because we know that sugar is not good for you. Sugar will not lead you to live longer. What's happening is probably a third variable. What's happening is that the people who eat candy differ than people who don't eat candy in various ways. People who eat candy tend to be somewhat more relaxed and have less stress than people who don't eat candy, who tend to be more stressed. And we know that stress is harmful to your health. Stress can cause premature death, right? So what's happening here is a third variable. Stress is related to people not eating candy and is itself related to dying early. And being more relaxed tends to lead to eating candy and tends to lead to a longer life. So there's a third variable at play here. Next example, eating pizza prevents cancer. If only that were true. No, this is based on an Italian study, okay? On BBC News, this is a number of years ago, and based on the study, which showed that in Italy, people who ate pizza tended to have lower cancer rates than people who didn't eat pizza. And the reporter mistakenly concluded that therefore eating pizza cuts cancer risk. Eating pizza protects you from cancer. Now, they speculate that could be because of lycopene in tomatoes. Okay, that's one possible explanation. However, because it's a correlation, we don't know for sure whether eating pizza is causing them to have lower cancer rates. It could be something else. There could be some other variables going on as well. And in fact, at the end of this article, they speculate that in fact there's a third variable going on here, which is that in Italy, a lot of people adhere to what's known as the Mediterranean diet, which is one of the healthiest diets that you can have. It's characterized by eating like olive oil and nuts and fresh vegetables and fruits and things like that. And the type of person who tends to eat the Mediterranean diet, which is known to be associated with lower rates of cancer, they also tend to have a lot of homemade pizza in Italy, at least. Right? So what's probably going on here is not that pizza is lowering your cancer risk itself, but rather that people who eat a Mediterranean diet, well, they tend to eat a lot more pizza, and they also tend to be healthier because of the Mediterranean diet. As a consequence, eating pizza is associated with lower cancer rates. Okay, now what I want to do is have you guys do the same thing. And so I'm going to give you a couple other examples of correlations, and I want you to give me possible explanations as to what might explain the correlation. So this was a study that came out a number of years ago that showed that couples who live together prior to getting married are more likely to get divorced after they get married. And I'll show you this study. I think this is in CNN where they showed this. Yeah. This is a correlational study. And they mistakenly concluded, the reporter, that living together may lead to breakups. Okay, so they're inferring or they're implying a specific causal relationship. That it sounds like the study is saying that if you live together, that can cause you to break up once you get married. But there are other explanations for this as well, other than this explanation. So does anyone want to take a shot in the chat as to what would explain why people who live together are more like before marriage are more likely to get divorced? Okay, so it could be the case that they moved in too fast. Okay, so what you're effectively saying is there's a third variable here, where there's certain couples who tend to move too quickly, and those couples are going to tend to move in really quickly together, and because they move too quickly, they're also going to tend to get divorced more quickly. So that'd be a third variable explanation. Affairs from boredom, yeah, okay. So you get bored with your partner if you live with them ahead of time, so that could lead to divorce, okay. There's a specific one I'm looking for, which is probably the true explanation, which I have not seen yet. Anyone want to take a shot here? Okay. Impulsive movement, impulsive to force. Yeah, okay, so you're capturing sort of what it is. So what you're saying is, again, there's a third variable here where people who are naturally impulsive might move in with their partner before marriage, and they also might be more likely to get divorced. You're kind of getting close. The explanation that I've seen is that people who tend to live together before marriage have different sets of values, right? They tend to be more democratic. They tend to be less religious. Okay, and people who are more democratic and less religious are more likely to consider divorce as an option if things go wrong later on in the marriage. Whereas people who are more conservative, who are more religious, are less likely to live together prior to marriage and less likely to consider divorce as an option once they get married. So what's likely happening here is that there's a third variable, which is your political or religious beliefs, that's leading people to be more or less likely to live together and more or less likely to break up later on. Okay, kids who watch a lot of television are more likely to develop attention deficit hyperactivity disorder, ADHD, later on in life. And it's tempting to conclude on the basis of that finding that therefore watching television causes ADHD, right? But that's probably not what's happening here. So I don't know what's happening to explain this explanation, to explain this correlation. Any guesses in the chat? No guesses at all. Okay, well, I'll give you the answer then, if I'm not getting anything. The likely idea here is that kids who have ADHD can be genetic. That's partly parents of the third variable. Okay, so that's getting close. No, okay. So yeah, some people are kind of getting it a little bit now. So what's happening here is that parents of kids who have ADHD can get exhausted because their kid's running around all the time, right? And so they need a break every now and then. And when they have a break, they take their kid and they put them in front of the TV because the parents need a break from chasing after them all day, right? So what's happening here is that it's not that television is causing ADHD. It's that kids who already have ADHD are more likely to watch television because their parents are putting them in front of the television, right? So it's not that X is causing Y, it's that Y is leading to X. Kids who have bigger feet are better spellers. Why would that be? Speed of development, yeah. Or to put it a little more simply, age, right? Older, yeah. Kids who have bigger feet are older than kids who have smaller feet on average. And kids who are older are better spellers on average than kids who are younger. So it's a third variable here, right? Age is causing increases in foot size and it's causing differences in spelling. So you get this correlation. People who use condoms are more likely to get sexually transmitted diseases than people that don't use condoms. On the basis of this finding, this is a true finding, on the basis of this finding, some people mistakenly concluded you shouldn't use condoms. It's going to increase your likelihood of getting STDs. And that would be the absolute wrong conclusion to draw here. They're inferring a specific causal effect here. Any reason why? There's a really, really simple explanation. That's going to be really obvious once you hear it. No, you guys aren't quite there. Although, okay, so some people are suggesting, I guess that could be true, that people who already have STDs are more likely to use condoms because they know they have STDs. So, and that also could increase the risk. There's an even simpler explanation here. Oh yeah, someone got it. Anna got it. People who are using condoms are having sex, right? Why else are you using condoms? There's people who aren't using condoms. Some of them aren't using them because they're not having sex, and so they don't have an opportunity to use condoms, right? So what's happening here is that people who use condoms have more sex than people who don't use condoms, and therefore there's more of an opportunity for them to spread STDs, even if they're using condoms like 95% of the time. Right? Okay, so do not conclude that condoms cause STDs. They do not. They reduce STDs. Okay, use condoms. Kids who have high self-esteem tend to do better in school. Why might that be the case? Yeah, so kids who have high self-esteem have better grades. So why? Okay, so okay, so people have got a couple explanations here. So it could be the case that having high self-esteem, you're more confident. So that maybe that confidence or that drive, that motivation helps you do better in school. That's like X causes Y. What looks to be the case is more that Y causes X, which someone said here, Carolina, I think you said that. It could be the case, not that self-esteem causes academic achievement, but it could be the reverse, that doing well in school raises your self-esteem, right? So academic achievement causes self-esteem. So Y causes X. It's probably a little bit of both. I think it's probably more academic achievement increases self-esteem. I think that's what the research shows, but it could be a combination of both. And that's actually an important point, is that it's not that only one of the three explanations can be true. All three of the explanations can be true. It could be that there's all sorts of factors. It could be that self-esteem causes academic achievement. It could be academic achievement simultaneously causes self-esteem. It could be third variables that cause both. It could be very, very complex relationships here. Last one, people who own hurricane shutters are more likely to experience damage from a hurricane than people who don't. So sell all your hurricane shutters, right? Wrong. Obviously, there's no connection. There's no causal direction, X causes Y, right? It's obviously not the case that owning hurricane shutters causes people to experience damage from a hurricane. So what's going on? Depends on location, as people are saying in the chat. That's right. So when I lived in Iowa for 5 years for grad school, I never owned hurricane shutters, never had a cent of damage by hurricanes, right? I moved to Miami, I've owned hurricane shutters, and I've had a window broken from a hurricane, right? What's happening here, of course, is that there's a third variable, your location. If you live in a location or a place where people get hit by hurricanes a lot, you buy hurricane shutters, and you're also more likely to experience damage from a hurricane. So it's a third variable here. Okay, I went over a lot of different examples of this because it is extremely easy to mistakenly fall for this idea that just because there's a correlation between the two things, that there's a specific causal direction between the two. And you cannot establish that with correlational research. Now, the advantage of correlational research, as we'll see when we talk about experimental research, is that it's only with experimental research that we can study real-world factors that cannot be manipulated in a lab. And I'll be with you in just a second, Daniel. So for instance, we're going to see that when we look at experiments, experiments involve manipulating variables. There's certain variables you cannot manipulate. You can't manipulate if someone is a male or a female. You can't manipulate what race someone is, what social status they are, et cetera. And what that means is you can't do true experiments on those variables. But that doesn't matter for correlational research. You can still do correlational research on those variables. So it's a little bit more flexible than experimental research, as we will see. The disadvantage, of course, is that we cannot make causal claims from the results of correlational studies. No matter how tempting it is, no matter how seemingly obvious it is what that causal direction is, we cannot make causal claims from correlational research. A causal claim is going to be the strongest type of claim that we can make. And therefore, it requires the most amount of control as a researcher. And we don't have enough control when we're conducting correlational research. We're only collecting data. We're not controlling anything. Okay, Daniel, you should be able to unmute. Yeah, do you have a question?
Oh, I have a question?
If you're Daniel and you raised your hand, I thought you did.
Oh, I didn't believe I did. Sorry, it must have been an accident.
Okay, no problem.
My apologies.
Yep, not a problem. Okay. So the last type of research that we're going to discuss, and what I mentioned in last class, which is really the bread and butter of social psychology, is experimental research. And the purpose of experimental research is to explain social behavior. We weren't able to explain behavior with observational research or correlational research, but we can with experimental research. And that's because of how experimental research works. I'm going to explain the logic to you so you can understand why it's only with an experiment that you can make causal claims. And because in social psychology, we want to make causal claims, we want to say that X caused people to behave a certain way. That's why in social psychology, we rely on experiments. So when I say explain social behavior, what I mean is we can make cause and effect claims. We can say that people behave this way because of some variable. Now, in order to be able to do this, there are two key aspects to experimental research, both of which have to be present in order to be able to make causal claims. The first aspect is that there's at least one variable that is being manipulated or controlled by the experimenter. And I'll give you an example in a second. And confounds, which I'll also explain in a second, are eliminated. We're going to come back to this point in just 1 second. Okay. But the second key aspect of experimental research is that we use a process known as random assignment. Now, the purpose of both of these aspects is to eliminate confounds. And it's only by eliminating confounds that we can make cause-effect claims. So let's take a deeper look at what that actually means, okay? So we're gonna start by looking at this first key aspect, the fact that we can control or manipulate at least one variable and eliminate confounds. Let's take a look to see what that means. First off, we have to make sure we're using the right language here. We're on the same page. So some of you, I'm sure, are already familiar with the difference between independent and dependent variables. In case you're not, let me just go over it quickly. An independent variable is a variable that a researcher manipulates or controls. Another way to think about it is it is the cause of a cause-effect relationship. So if you're interested in looking at, for example, whether watching violent TV causes people to behave aggressively, then your independent variable, the cause, is the violent TV. That's what you're going to manipulate in your study, how much violent TV someone watches. Okay? It's called independent because the researcher has control over it. It's independent of anything else. They get to choose what it is and how to control it. In contrast is the dependent variable. The dependent variable is a variable that is not controlled. It's only measured by the researcher. Or another way to think of it is the effect of the cause and effect relationship. So if we're looking at violent TV's effects on aggression, then the dependent variable is aggression. It's the outcome variable. We're not making people more or less aggressive. We're simply measuring how aggressive they are. Okay, so here's the example that I use. All right. So again, the independent variable is the cause. The dependent variable is the effect. Okay, so I mentioned in correlational research, one of the advantages is that we don't have to manipulate variables, right? In other words, in correlational research, we don't really have independent variables because we're not really manipulating things. We're simply measuring variables. It's only with experiments that we now have independent variables, because an experiment gives the experimenter control over the situation. And by control, I mean they have the ability to manipulate these variables. So what a researcher might do, for instance, is if they're interested in this research question, you can take a bunch of kids one at a time, and you can have some of them watch a lot of violent TV, and some of them don't watch any violent TV during an hour-long period or something. And then you can measure them using some measure of aggression to see if they behave aggressively. And the logic is that if you take kids, and if the kids who watched violent TV behave more aggressively later on than the kids who didn't watch violent TV, then we can attribute that, as long as we've conducted the study properly, to the fact that they watched aggressive TV. But let's look into this a little bit more, because it is very, very easy when conducting these studies to accidentally introduce confounds into our research methodology. So let's talk about what a confound is and why it completely destroys an experiment. Okay, you want to avoid confounds at all costs. A confound is any extraneous variable. Extraneous meaning it's not the independent variable. Okay, it's something else, something we're not trying to control, that may influence the dependent variable in a systematic way. You can kind of think of it as it's anything that differs between your groups other than the independent variable. So let's take the example we've been using so far, right? So let's say, again, we're looking at the effect of violent TV on aggression. So violent TV is going to be our independent variable. We're going to have people watch either violent TV or not, and then we're going to measure their aggression later on. Now, let's imagine that we have two groups of people. So 50 people who watch violent TV, 50 people who don't. If those people, if those groups are equivalent, meaning if the 50 people who watch violent TV are the same as the 50 people who didn't watch violent TV. And then we measure their aggression. And only the people who watch violent TV are aggressive. Well, the only reason we have, the only explanation for why they're more aggressive is because of the violent TV that they watched, because they're identical in every other respect, right? That's why if you properly conducted experiment, you can make causal claims. Because the only explanation we have for why the groups differed in aggression is because they differed in how much violent TV they watched. So therefore, we can say violent TV caused aggression. But let's say that when we conducted our study, we conducted it in such a way that our two groups of people, those who watched violent TV and those who didn't, differed in a couple of other ways as well. So let's say that the kids who watched violent TV, let's say they also tended to come from families where the parents weren't as involved in their lives compared to the kids who didn't watch violent TV. And let's also say that they tended to lack social activities. They didn't have a lot of sports or clubs or events that they would go to compared to the other kids. So now, in other words, our two groups differ in three ways in terms of how much violent TV they watched, how good their parents were, how many social activities they had. And so therefore, if we find that the kids who watch violent TV are more aggressive than the kids who didn't, we don't know if that's due to the fact that they watch more violent TV, if it's due to the fact that they came from families where the parents had different skills, if it's because they lacked social activities. We don't know which of those explanations explains why they're more aggressive. So what that means is these are the variables: poor parenting, lack of social activities. These are confounds. These are variables that differ between our two groups, other than our independent variable, that could explain differences in aggression. And so you can see that when you have these confounds present, we can no longer make causal claims because we don't know which of these things is responsible for the differences in aggression. So the main purpose, or one of the main purposes in designing a proper experiment, is to eliminate confounds as much as possible. Okay? If you have a confound present in an experiment, we cannot establish cause and effect relationships, which is the whole point of doing a study or doing an experiment. So a single confound completely destroys a study. So the purpose of designing a proper experiment, which can be a very tricky thing to do, is to eliminate every confound possible. And there's two ways of doing that. The first way of doing it is to design your study such that the people in your groups are treated absolutely identically in every way possible. You don't give different instructions to people who watch violent TV and people who don't watch violent TV. You don't do anything different with those groups. You treat them exactly the same to make sure they're equivalent between those two groups, right? I'm going to give you the second way in just a minute. For now, what I want you to do is tell me whether there's a confound in this hypothetical study. So imagine that a researcher is interested in looking at the effects of attractiveness on hiring practices. And so what he does is he sends out attractive men to interview for jobs, and he sends out unattractive women to interview for jobs. He finds that the attractive men are hired more often than the unattractive women, and concludes that being attractive leads to better chances of being hired. So is there a confound here? Well, this one should be pretty obvious that there is, because what they want to do is they want to look at the effect of attractiveness on hiring practices, right? So attractiveness should be the only thing that differs between these two groups. You should have a group of attractive people and a group of less attractive people. There should be no other differences between the two groups. The question is there another difference between the two groups? Clearly there is in this case, right? He confounded the sex of the person who's interviewing with how attractive they are. He only had attractive men and unattractive women. As a consequence, when he finds that attractive men are hired more often, we don't know whether that's because they're more attractive or because they're men. Maybe people just wanted to hire men more than women. We don't know, right? There's two possible explanations, and therefore, because that confound is present, we have no idea what caused it. We can't establish a cause-effect relationship. That confound destroyed that study. Or take another example. Let's say a researcher wishes to study the effects of TV violence on aggression. So half of his participants watch an hour of violent TV. The other half, during that time, listen to an hour of relaxing music. So participants who watch violent TV display more aggression than participants who listen to music. So the researcher concludes that violent TV causes aggression. So is there a confound in this study? Okay. Well, again, we're going to compare our two groups. We have a group that watched violent TV and a group that didn't, right? That's our independent variable. Did our groups differ on any other variable as well? Well, it should be fairly obvious to people that they did, because one group of people listened to relaxing music and the other group didn't. So now our two groups differ in two ways, in terms of whether they watched violent TV, in terms of whether they listened to relaxing music. So maybe it's the case that watching violent TV increased aggression, but it's equally plausible that maybe the group that listened to relaxing music instead of violent TV, maybe listening to relaxing music lowered their aggressiveness. Both of those are possible explanations for our findings. Therefore, we can't establish any causal effects. We don't know which one caused the effect. Right? So, when designing an experiment, we have to make absolutely sure that our groups don't differ on anything except for our independent variable. So we have to design experiments really, really carefully to make sure we don't have any confounds in them. Okay, I mentioned that there are two things we have to do to eliminate confounds, right? So the first one is make sure that when we design our study, we design it such that we treat our groups the same. The second thing we need to do, and the second key aspect of an experiment, is that we have to use what's known as random assignment. Now, we talked about random sampling before, where everybody in a population has an equal chance of being in our study, right? Random assignment is a little bit different. Random assignment refers to the idea that everyone in our study has an equal chance of being in any condition in our study. So what will often happen in actual studies is that when a participant shows up to our lab, we will randomly assign them to conditions. We might literally flip a coin to figure out which condition we're going to put you in our study, or we might use a random number generator or something along those lines. Okay. Now, by using random assignment, and only by using random assignment, can we also ensure that our two groups are the same in terms of demographics? So for instance, if we have 50 people in a group that watches violent TV and 50 people in a group that doesn't watch violent TV, if we use random assignment, we can ensure that on average, our groups are the same in terms of the average age of people in that group, or the average income of people in that group, or how many men and women are in each group, or the racial makeup of the group, or in any variable we can imagine. Statistically, random assignment ensures that on average, those groups are equal. Okay. That's great because that means that we don't have to make sure that our groups are equivalent in terms of age and race and sex and 50 million other variables, because random assignment automatically takes care of that. Now, just because you have random assignment doesn't mean that you might not accidentally introduce other confounds into your study. You have to use both random assignment and a proper research design to make sure you're not treating the groups differently. Okay? Both of those things are absolutely necessary in an experiment. Because if you don't have that, you can't ensure your groups are equivalent, and therefore you can't make causal claims. You can always have confounds in some way. So the only way to get rid of confounds is to both design your study properly to ensure no differences between groups, and to use random assignment to make sure that demographic factors cancel out between your two groups as well. In every experiment that you will learn in this class, every single one will have randomly assigned people to conditions. If you don't randomly assign people to conditions, you don't have a proper experiment. Okay. There's just a minute or two left. Does anyone have any questions that you want me to address in the minute or so we have? I've only got a few slides left in research methods, and then we can move into some actual social psychology starting on Tuesday, and things will get a little bit more fun, I think, on Tuesday once we get past this stuff. So remember that we are almost certainly going to have a Top Hat quiz on Tuesday. Make sure you have your Top Hat account ready to go. Can you find, yeah, the PowerPoint, all the PowerPoints, all the slides are up on Canvas already in the module section, so you should be able to find them there. So we'll finish up talking about this section on Tuesday, have a Top Hat quiz, and then we'll go on and start talking about some real social psychology. All right, guys, have a great weekend. I'll see you next week. Bye.